Hi everyone, welcome to Good Kamkaj YouTube channel. I hope everybody are doing good. In the last sessions, we have seen how to create a Docker image, and we have seen what all necessary are required to create a Docker image, and we have seen how to create a container from the Docker image, and we have done the port forwarding, and we have seen how to access the running application instead of Docker container, and we have exposed that with IP address, and we have seen how we can initiate that with a Docker hub in our machine. So today we are going to discuss about the same thing, whatever 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 operation we have done with a Docker desktop, which means we barely create one a Docker container from the Docker image, and we have ran that container with a port forwarding of 5000 with a detached mode. So today we are going to see how can we deploy the same Docker image as a container inside of a pod into the Kubernetes orchestration tool. So that's the final goal. And I brought one schematic diagram, what all operations that we are going to perform in this entire video. And for information, this is the manual deployment that we are going to do into the Google Cloud Engine. And you can ask me, hey, why did you take the Google Cloud Kubernetes Engine? Sorry. So the reason why, if I'm using a Docker desktop, which is running in my local, so if I'm using that, what would be happen? So I cannot expose my Docker container to the external world. So, and since Kubernetes is running on top of Docker hub, but sorry, Docker desktop. So that is the issue currently I had faced. Um, I cannot expose my. Sorry, I need to delete this images. So I cannot expose my running application instead of Kubernetes to the external world. So for that, I need to create a load balancer and all. So it's kind of bit headache to perform such operation. Instead of that, so what I have done, so I have taken one Kubernetes cluster instead of Google Cloud Engine. So I'm going to use that. If you see this one, so I have the Google Cloud Engine up and running in my in this particular console. So I have login as a Cloud Shell, and let's see, that's all about the Google Cloud Engine. And so the first operation that whatever image that is available in our local machine, so which means here, and we are going to push that image into hardware image registry. So usually in the current market there are hundreds of image registries are available. You can say that, hey, we have the uh, Azure Content Registry, and we have, you can use the AWS ACR, Amazon Content Registry, and we have the Azure registry also, and Docker Hub. So each tool has given set of principles and policies to be used. So to not make this complicated, I'm going to use Docker Hub as an image registry. I'm going to push the local image which we built in the last video, and I will explain you how we can push it by adding your credentials, and to pushing your image from your local laptop to, I mean, from your local to the Docker hub. So you should have a Docker account over there. So I'll show you how you need to register and all. And after that, you need to create a repository. I'll show you how to get a repository, and later you need to um, tag the image, and you need to do the authentication and all. I'll show you what all things to be done. But so for outer layer, now we are going to push the locally available Docker image into Docker Hub here. And after pushing that image into Docker Hub, again, we are pulling the same image into the Kubernetes cluster. And we are going to see how we can, after pulling the image, whatever we have pushed into Docker Hub, after pulling it, and how we utilize that to get do a deployment of Kubernetes. And we will see how we need to write the Kubernetes manifest files. In our case, we need to write the Kubernetes deployment file and service file, and we'll see what all components are available inside of that two files, and how we can expose our image as a container instead of Kubernetes cluster. So that's the final agenda, and at the end, we will see, as an end user, we'll access that particular, we'll access the particular IP address as end user, and we'll see what all operations that we have done when we ran the same container into on top of Docker desktop, and that response has to be given the same as when we will be running on Kubernetes cluster. So stay tuned until this video. I hope it is clear for everybody. Here we are not doing any super complicated. We are just adding a one component or tool called as a Kubernetes. It's orchestration tool. It's widely used and it has a lot of advantages like auto scaling and auto healing and exposable and config maps and secrets whatnot. So there are hundreds of bunch of features are available. That's why as a real time. So what people do, they deploy their any content runtime into any orchestration tool. So orchestration tools are available in a market, or like you can use a Docker Swarm, and you can use a Kubernetes, and you can use the OpenShift. So there are hundreds of Kubernetes cluster. I mean, hundreds of orchestration tools are available. So it's up to you which one you would like to use it, and it's up to your business and the budget for your environment. So there are a lot more to be considerable when we comes to Kubernetes and Kubernetes planning as architect level. So, but yeah, this is agenda. Like there is nothing much complicated. We are going to do a manual deployment. There is no any automation here in this video. I'm giving you this information at the beginning of the video because when would like to do automation. So first we need to understand how the manual things works, and later we can easily jumping into how we can make this automation easier and more robust. So that's all. I hope it's clear for everybody that whatever we would like, we are going to do in this video with this entire Docker, Docker Hub, and all the Kubernetes cluster. So first, first let's build the image. So currently, I don't have image which is up and running with the name of Flask. I just have deleted, so it's not showing here in my Docker desktop. So currently, it's running on my local. So first, what I will do, I'll build a Docker image, and and after that, I'll do all the operations, tagging and Docker login, everything. So step one, now I'm going to build the same Docker image that we have seen in the last video. So the command that I'm going to, so sorry. So here I'm going to use some commands that we have already seen in the last videos like Docker build and all. So there is no code change here. Like, I think I have done some slight changes. Let me see what changes I have done. Welcome to production page. I think I haven't done any, much more complicated changes here. So it's very similar one for everybody. So the same source code that I'm going to use here itself. So to build the Docker image, so if you see here, we have a Docker file and the Flask app. So if I do ls, you can see the Docker file on the repository. This is a Docker file, and just for information, I just have print this. So nothing much, and look controller. So I'm going to build a Docker image. For that, command is docker build, and hyphen t is a tag, and after that I'm going to specify the name of my application, which is a flask underscore ml underscore app. So this is the image name that I'm going to specify. I'm going to give as a dot, so it is going to find Docker file wherever it is on the root level, and it will build it. There is not any changes has happened in this command, that we have done the same thing in the last video. Fine, we have built the Docker image. Now you would like to tag the image. So in the last video, what you have seen, we slightly create the Docker image or Docker container out of the Docker image that we have built. But so now we would like to tag the image and we would like to push that image. So let's see what is the image that we have built, and let's what is the name of that, and on all those things. So the command to list out all the images. So Docker image ls is the command, and it will list out all the images that are available in the machine. If you see this one, so Flask app, and it has just created, and which is as a file that fine. So we have seen that we have built the Docker image. If you come back to the Docker desktop, it will show you the same image. So if you see this one, it will just have created with the size of 538. So in the last video, what we have seen, like we have build the we have, after building the Docker image, and we ran the image as a container, and after that we access the application. In our case, now we would like to push the same image. If we come to the this architectural diagram, we just have built it. Now we have to push the image which is available in the Docker, I mean which is available in your local laptop, to the Docker hub. So if you see this one, this is the Docker Hub, hub.docker.com is a URL. So you can come here and you can create your account. It's very simple. There is no much complicated. You just need to give your email ID and unique unique name and the password. Three things, totally fine. There is no much complicated. I'll add the URL of this hub.docker.com if you have any hard time to find it. And here I am the user. So here my name is Sheikh and my unique name is a byte, and I have its own set of password for to access this repository. And these all my repositories that I have used since long time. And if I want to push my specific image from my laptop to the Docker Hub, I need to create a repository. It's similar like a Docker Hub, guys. There is no complicated. So if you want to push your specific code to your Docker Hub, so what you will do, you will create a repository, right? That's the same thing. There is no much complicated. So I'm coming here into my Docker Hub. I'm going to create a repository. So I'm going to give a name as MlOps. MlOps is my repository name, and you can give a short description what why this repository is and all. So what I will do, I will mention that uh, will keep all MLOps images here. It's up to you, like what description you would like to give. And the next thing, visibility, guys. Visibility same like Docker Hub. So there also you can keep your source code as a public and private. So in our case, I don't want to make any complicated. That's why I'm keeping this Docker Hub repository as a public. Sorry, public. So anybody can come here and you can access this repository. I just press on create. So if I press on create, it what it will do, it will create one image registry on your name username with the MLOps. And if you want to push any image into this particular repository, and you need to use this command docker push. This is my repository name. So this is my username and this is the repository name and the tag that you are going to give for your image. So this is how we can create a repository inside of Docker Hub, and we can push it. So let's go back to our terminal. So now if you see this one in the last command that we have just do a Docker image ls. Now it's time to tag the image. So whenever you push, you need to tag the image. So you can give any number of tags that you would like to use it, and it can be any tag. It can be latest. It can be any version that your source code is available in that particular image. So for that only, I'm going to give a tag for our image. So that I'm going to specify Docker tag is a command, and after that I'll specify the image name first underscore ml underscore app is my sorry ml underscore app is my image name, and after that I'll specify the shake byte my username, and mlops is my registry, and I'll specify the latest is the image tag. So you can give any image tag instead of latest. You can give a v1, you can give a v1.0, or you can give a today date. So today is the 31st of August. You can give any number of date or timing. It's up to you guys. So it's up to your naming convention that you would like to follow. So in my case, I would like to give a latest because this is the latest image that I'm going to tag it. So it's a very fresh image. So that's why I'm specifying the Docker tag as the latest. If I press enter, the Docker tag has been created. Now, whatever image has been tagged here in your local machine, you have to push that image from your local to image registry, which is your Docker Hub. For that, so how can you push it? So usually, like what we in typical days, what we do, we just do any kind of SSH, all the operation that we used to perform in the traditional way. But when Docker Hub came, so they're saying that hey, if you want to push any image which have tagged in your local laptop, so you just need to pass few commands. You can authenticate yourself in the CLI itself. So in my case, like I haven't done any authentication here, so I cannot push image to this one. So if I do any pushing here, if I perform any Docker push, if you see one Docker push is the command that we regularly use it. So and the tag is shake byte. MLOps, this is my entire username and repository, and the latest is my tag. If I press enter, it will say it will trying to prepare and it will do something saying that hey, denied, request access to the resources denied, which means like hey, you're trying to push this specific repository with the username with the tag of latest, but you don't have a authentication or authorization to do this. So for that, if you want to push any image which is available in your local, for that you need to do some login to your image registry via CLI. The command is docker login. If I press enter, if say that hey, you are going to log in with your user ID or email address, push to you pull image from your Docker Hub, which means like you're going to connect your terminal, your CLI with the image registry which is available here. So if you want to push, in our case, if you want to push image which is available in our local, we need to authenticate ourselves. So for that, it is asking username. In my case, my username is ShakeByte, and I'm going to specify it. ShakeByte. If I press enter, it is going to ask the password. So the password would be the password that we have used to create account. So I have used my password to create account. So I'm going to specify here. If I press enter, it's going to take a little bit time to get the question. If you say this one, login is succeeded, which means we have successfully logged in from your CLI to image registry. So now what we can do, we can perform the action that we used to do. So if you come here and now this is the ShakeByte MlOps repository. Currently we don't have image tagged here, and nothing is available. If I do even a refresh, the page will get refreshed and it will show the empty. We don't have images has been pushed from your local to image registry. So if you want to push that image which we have tagged from your local to image registry, you need to use this command docker push, and after that this one. If I press enter, what will happen? This will specify pushing refer to repository docker.io shakebyte mlops. So it is the Docker tool that we have used as a as a web console or whatever you call, and this is my username and this is my registry. Very clear. And now it is pushing, which is I think around 500 MB of my Docker image each side. So now it is pushing all the way image from my local to image registry. So if I go to the diagram, so now we are doing this operation. We are pushing this image, um, which we tagged here, and we're pushing the same image into the MLOps repository, which is available in the Docker Hub. If I come back, now it is pushing, and let's wait. It's going to take very little bit amount of time to do this. So if you see this one, latest tag, this is the tag, and this is the size of it. And if we come back, and if I do refresh, the image will be available here. If you see this guy, so this image is available and they pushed very few seconds ago. We have just done pushed here, and we just came from the CLI to this console. Now we can see this one. This is my tag available here. I hope it is clear for everybody, like tagging and pushing into image registry and all. Now, so we have done the two parts. The first one is if we come to this diagram, the first one is we tagged and we pushed it. Now we are going to use that image, which means we are going to pull that image. If I make you more easy, pull tagged image into the Kubernetes cluster. So whatever pushed here into this Docker Hub, we are going to pull that image into Kubernetes cluster. I already show you that I have taken the Kubernetes cluster in Google Kubernetes engine. So if I refresh that for make you more sessionable as a latest. So now it is loading. So if I do press on connect, I will connect to my Cloud Shell, and I just need to pass few commands. I think it's a single command that it will take to connect your Kubernetes cluster. So this command is automatically appended. So if I press enter, it will show you the kubeconfig entry generated into for MLOps. So my cluster name is MLOps. That's the name of mine. So if I want to interact with this one, this particular Kubernetes cluster, kubectl get pods is the command that you can interact with your Kubernetes cluster. If you see this one, no resource found in default namespace. So currently we don't have any resources have created into our default namespaces here. Clear? So I just have interacted with my Kubernetes cluster. There is no much complicated. So that I used to do the same commands on Docker desktop. So that I have used to do the same command Docker desktop. I haven't done any complicated task here. I just have listed all the pods. So if you have any pretty confusion, okay, what is mean by that and how we can do this, you can watch my previous videos like on Kubernetes listing pods on. I think I have created the same command that I have used to explain how to install a Docker desktop and how to enable the Kubernetes. So if you have any few confusions, you can go back to that and you can watch that video in this playlist. So you'll get more familiar with that. Fine. So now we are going to deploy this image, or now we are going to run this image as a container instead of Kubernetes cluster. But how? So if you want to create any deployment instead of Kubernetes cluster, you need to follow few set of principles. Those principles are like, you need to create a manifest file for that, and you need to expose the service as a cluster IP node port or load balancer if you want to make accessible to the end user who is available here as end user. Now we are the Kubernetes cluster. So for that, if you want to make any Kubernetes deployment, so you can barely write any commands to create a pod, but if you want to expose your container to the external world, so you need to write two files. One is Kubernetes deployment file, another one is a Kubernetes manifest file. So I have written those files, and I'm going to show you those files are here. Oh, where are they? Where are they? So let me come here. Code. Sorry. Let me take a CMD here and code dot. So I'll use another tab for this to make you understandable. So I haven't keep these files along with my source code because I don't want to get this copied into my image, and I don't want to do this more complicated. So that's why I kept as a separately. And so this is the Kubernetes deployment file, like, and if you want to expose any pod to the external world, you have to use a deployment as a controller, and you can see here. So we have the few set of components that we have written as a Kubernetes, specifying, hey, if you want to deploy any Kubernetes controller as top of your pod, and you need to follow my set of principles that I have been instructed. So for the first one is the API version, saying that, here in the line number one is saying, specifying the Kubernetes API version which is using, and kindly specifying that what kind of object that we are going to use here. So our object is deployment, and the sorry, third one is the metadata. It's containing the metadata of objects, in our case, like, the deployment name. So the deployment is meta MlOps production. And the second one is the specs. Specs. So specs describe the desired state of your objects. In our case, like, we have the replica one. So how many pods you would like to create, which means like each pod can have one or more containers. So in our case, we are going to create only one container. So we're going to have one pod, and in that pod, we are going to run the image that we have built and pushed into the Docker Hub, and we are going to pull that image into our Kubernetes cluster. And you have seen the replicas. And next one is selector. So selector is something that, which define how many copies of your application you want to run. And here it means like, sorry, I confused. So selector is something that, it's defined the, like, how you like to identify your pods, which is managed by deployment. So you can specify the label for that. If you see this one, we have the match label. In that label, we have the MLOps reduction is the match label for that. And the next one is template. So in the template section, you need to specify desire. I need to, on the other hand, we can say you need to describe the pod that you like to create it by the deployment. So you need to specify all the information. And this under template, we have the metadata, which contains the label information. So in our case, like, we have label the pod, which is MLOps in production. And the specs. So on the specs, again, we have the specs section under the pod, which is describe the container, and which describe the container and that will run inside of the pod. And here we have specified the spec for that. And in that, what is a if you see this one, the containers is specifying that, specific list of container we have taken over here. In our case, we are taking only one container. That's why we are name it as a list. And name of your container. And image section, we need to integrate that image that we have pushed into image registry. I'll add that at the end of the explanation. And the next one, so port is something that, the port that the container will resign, which listen, and you can specify the port number for your container. So you need to specify all these things if you want to do a Kubernetes deployment. And the other section we have is a service. So in the service, API version is same, and kind is here that we are going to specify the object type is as a service, and we have the metadata, which is contain the metadata information about the service, which is in other hand service name. And we have the specs which describe the state of objects, which is type, specifying the type of your service. And in our case, we are exposing to the external user. That's why I'm using the load balancer. And what is the selector for this? Like, you can specify the labeling for that, like what is label for this. In our case, we are specifying the MLOps as a prediction. And then the next one is a protocol, like, how would like to expose is a protocol, and we are going to use a TCP. And what is a port number that would like to expose as a service, and what is a target port. So you know, the port number exposed by the service, like the particular number can be external client will be used to connect it, so that's why I specified it. And the target port which is connect, that traffic will be forward to the specific container, so that's why it should be matched with a container port, so that's why I specify it as a 5000. So that's the two thing about the I mean that's the entire thing about Kubernetes deployment file and the Kubernetes service file. And I hope it is clear for everybody with the explanation in this video. If it is not clear, I requesting you to drop your comments in the video, and I'll make another video on top of it. So in our case, as I mentioned in the deployment, so in the deployment we are going to create a, you know, container instead of the pod. That's why you need to specify where your image is located. So in our case, our image is located into this image registry. If you say this one, this is our image registry. So for that, I'm going to use this as a ShakeByte MlOps tag name. So I'll give a tag name as a latest because this is my tag name. So if you see this is tag name, right? So and I'm going to specify the same tag name here, which is our case latest. Latest is the tag name, and I'll pull that image into Kubernetes cluster. So I have taken this just for explanation purpose on the Visual Studio Code. I will copy the same file from here, and I'll create the I'll copy this same content from here into my Visual Studio Code into my this one into my Google Cloud Engine. So I'm going to do that. So first I'll copy the Kubernetes. Sorry guys, I'm getting cough. First, I'm going to copy this entire section, which is our case, like, you know, all the deployment information. So I'm going to my GKE, Google Kubernetes Service, ls. We don't have any files over here. I'll create a file. The name is nano, and I'll specify the file name as the MlOps hyphen production hyphen deployment dot YAML. So YAML is the syntax that you would like to use it to create the manifest file of Kubernetes. If I press enter, I can paste over here. So I have pasted all the information that we have copied from Visual Studio Code to here. And this is our image tag and along with registry name and all. So I'm going to close this, Control X, Y, enter. Now I'm going to specify the service name also. For that, I need to create a service file. And later I'll apply it. So service name should be MlOps hyphen production, sorry, hyphen deployment dot YAML. Sorry, should be service. What happened to me? Service.yaml. And I'm going to my VS Code, and I'm going to copy the content from here, and I'm going to paste over here. So Control X, Y, enter. This is how you can close the Nano editor. And if I do ls, I have these files. If I do cat MlOps deployment, this is information which is available inside of this. And if I do, let me keep this up. Cannot. Okay, I think that's the only thing. Cat MlOps service.yaml. If I press enter, we have this thing. So the main thing, you need to be more cautious while you exposing your content in external. It should be load balancer. It should not be any node port or cluster IP. If you're using node port and cluster IP, so you're going to be you're going to be some trouble. But node port you can access as a cluster level, but you cannot access outside of it. That's why you should use a load balancer. Fair enough. Now, so if you go back to the diagram, so we have the we tagged the image, we push the image, and now we have the all the Kubernetes manifest file that are available in the Kubernetes cluster. Now while we applying that Kubernetes manifest file, the Docker image will pull from the Docker hub instead of my Kubernetes cluster. So for that, I'm going to apply those two. So for that, I'm going to say kubectl kubectl apply -f is the command. So guys, you should be more familiar with the Kubernetes commands while you're applying it and while doing all the troubleshooting, so looking into the logs and all. So be careful while applying and typing it. You may get typos, because I used to get the typos a lot. And this is the command that we like to apply. It's kubectl apply -f, and I'm specifying MlOps deployment, and I'm specifying both file in the single command. You can specify it's up to your requirement. You can do that. MlOps production service.yaml. If I press enter, kubectl file, what happened? MlOps production, unexpected arguments. Oh, there is some issue with that. Okay, okay. I think there is some issue with the typo, unexpected args. Production service.yaml. Cat MlOps production service.yaml. What can be service? We have load balancer production. What could be the typo next one? Let me pause this and let what could be the issue here, and I'll get back to you soon. Okay, so I have found that, like, there is no any issue with the YAML file. There is an issue with the commands that, if you say this one, like, the above command, I have passed kubectl -f as a file and I'm passing the two files without any flag. So that's why it has giving the issue. So I figure out that we should pass the -f for both files if we are passing a single command. So there's a solution for that. If I press enter, what will be happen? So my one deployment will create and one service will be created. If we do kubectl get all is the command, so it will list out all the resources which are available here in my namespace, which is in default. So if it is one, oh, the part is running. Part is running at the 8 seconds ago, and instead of part we have the container, and we have exposed as a load balancer. If you see this one, external IP is currently pending, and it will take some time to expose your container to the external world. So we have the IP address, which is cluster IP. You cannot access it. But if you want to access your container, which is running inside of your pod under the deployment, if you see this one, we have the replica set over here, and to which is on top of your as a controller is working on top of your pod, and on top of controller you have the service, which is the this one. This is the service, which is production, and you have the deployment here. This is the deployment. So the structure is, first it will be a pod. On top of your pod you will have a replica set, and on top of replica set you have the deployment. On top of your deployment you have the service. So in our case we have a service called as load balancer. We have exposed it, and it will give a external IP, and this is our port number that we are going to access that port number. And if I do watch kubectl get SVC is a service and a shortcut. You can use that. If I see this one, oh, external IP has been located. That's awesome. So what I will do, kubectl get all, both commands will work fine, but I just want to list out all the resources. If you see this one, we have the external IP, and we have given in our Kubernetes manifest file saying that, hey, I would like to have one pod up and running. Inside of pod, we would like to have this container. This is the container. Sorry, that's the name. This is the image has created as a container. Now we'd like to see all the logs or what is happening inside of the pod. So what you can do, let me clear this. So first I will get kubectl get pod is the command for pods. Maybe, yeah, now it is running. I'd like to see how logs are coming on. So for that I'll specify, or first let me describe what all happening inside of my pod. Kubectl describe and pod and the pod name. So this is how you can describe the pod name. I'm going to copy this. Let me copy this. There is some issue with this Cloud Shell, guys. Like, it cannot copy as easy as is it that you're working on Docker desktop. I copied it. Now it is going to describe all the information which is available inside of my pod, like what is IP address and which node it is taking and when it is started, what is the labeling. If you see this one, we have these labels and all annotation, what is the status, it is running or not, and controlled by which is replica set, and these all things. If you see this one, we have the image, and this is a shakebyte ML ops latest, and this is the image ID which is pulling from my public repository, and what is the port it has exposed. And if you come down, if you see this one, successful assigned the default MLOps prediction, and this is the pulling from my image registry, that is from here into my Google Kubernetes engine, and it successfully pulled and it successfully created the container, and it is successfully started the container. Now my container is listening on the port number 5000. So for that, what I will do, if I want to access that container which is running inside of my Kubernetes cluster, first I will list out all the services. Kubernetes get svc is the command. So I can see this service which is bind with this pod. So for that, I'm going to take this as external IP 34.70.78.178. Oh, I think it has not been copied. Here, I'm going to copy this IP address, and I'm going back to the same cluster, the same log. If you see this one, this is the external port. You can take this external port as a 5000, and I'll add over here with the 5000. So if I press enter, now we have the welcome to the sales production homepage, which means you have successfully exposed your machine learning model to the external user or external world, whatever you call. So we are at this place. So what we have done with this Kubernetes manifest file, we pull the image instead of our Kubernetes cluster. We have seen the logs, and after that we ran the pod and we exposed that pod with a service called as a load balancer. Now as an end user, I am as an end user, or if you anybody, you can give this IP address to anybody in the world, and if they hit this IP address on any browser, they will get this welcome page, any welcome page. It can be anything. So if you have cloned my repository, if you could do some customization, it can be visible here. And let's see what all operations we can perform over here. So like, first we have seen, like, we have a bunch of operations that we have seen in the when we run on manually. So the first one is data collection here. So first I'll specify, I'm just copying it the endpoint, guys, because those endpoints are not in my handy. That's why I'm copying it from the code. But in our case, you can have it handy, or it's up to you. If I press enter, now my data has been collected. Now I'm going to have the data pre-processing with my external IP address as a user. Not no, user cannot do all those things. But yeah, I'm just for domain purpose how we can expose any Kubernetes running pod direction, the machine learning model which is running inside of it. So I'm performing all the basic machine learning methods, which are model training and all, and model evaluation over here. I'm going to do that. And if I go back to my code, and the first one is predict. So predict, that we have seen, like, predict can be done with the postman. You need to pass few commands, which is the agent salary of the person, whether he's going to purchase or not. So for that, I'm going to use the postman. As a postman, I'm going to copy this IP address here, and oh, it is already available. So but before starting the video, I just have done some practice guides, that's why it is reflecting here. Yeah, so this is our external IP address along with the port number with the predict as the route. So I'm going to show you what all headers we have passed. Headers, we have the content type as application JSON, and the body I have passed age 35 and salary is 47,000. And if I press send, if I hit this call, what it will do, this IP address has accessed my machine learning model inside of it, which is up and running in the pod of my Kubernetes cluster. And I'll show you all the logs. How does the log look like? And with the endpoint of predict, so it is going to append these two values. With it is going to connect with the machine learning model, and this machine learning model will be validated with the trained data, with this current data from the user, and it will predict whether this guy will be purchase the product or not. That is what happened in the backend. And we have discussed the same thing in the last videos also, like how you can do the prediction with the endpoint. This prediction can be inaccurate because, if you come validate, where is this one? In the model evaluation itself, like, we have the less accuracy because we have the less data. We have trained with the less data, and that's why it has a less amount of accuracy. But yeah, our end goal is not to concentrate on the code. It can be concentrate on the code as a real-time MLOps engineer, but to make you more understandable. So I just brought some sample machine learning model, just get deployed as a manual into Kubernetes cluster. The end goal is that we have to automate this entire process as a CI/CD and get deployed into Kubernetes cluster. That's the end goal. But your responsibility is looking at the accuracy along with your data scientist or machine learning engineering gaps to your roles and responsibilities. But yeah, right now, this case we can ignorable. It can be ignorable. So that's all we have done. I think, first we have labeled it and pushed to the Docker Hub, and later we pull the same image into a Kubernetes cluster here, and we return the. We have seen all the Kubernetes manifest file, which is deployment and service file, and we have exposed our service to the external user, which is tagged to the one of the Kubernetes pod. In our case, we have taken one replica of the Kubernetes pod. Fine. Let's see the logs. Kubectl get pods is the command which is going to get the pod list, and I will have my pod name here, and I'm going to take the pod. Where is the copy, man? This is a bit of weird, like copying is kind of weird here. Kubectl logs, and I'm going to specify the pod name here, and it will give me all the logs of the specific pod. If I say this one, guys, so these are our logs. So we have hit it, and if you say this one, we have the data collection, data pre-processing, EDA, feature engineering, model training, and after that, we have done the model evaluation here. At the end, if you say this one, we have the model predict. So it's saying the HTTP 200. So this is all the operations we have done with this IP address, like 100, 101.0.62.205. That's my public IP address. I think if I can browse here, my public IP. What is my public IP? I think it has to give us dynamically. Let me see here. So this is my public IP address. So this one, 101.0.62.205. The same one has came here. This is my public IP address, which has hit to this service, which is running inside of my Kubernetes cluster, and we have seen all the response all the way coming to your browser. So we are not going to perform all the actions that is available in the code as the end user, because end user doesn't care about all those things what is happening in the behind the scenes. He only care about the prediction. This endpoint can be anything, like as per your while evaluating your writing the application, integrating the API somewhere. It's up to your whatever name you would like to give. But my case, to make you understandable, I give it as a product. So I hope it is clear for everybody. I think if I take the diagram as a reference, I have covered everything. It's clear for everybody. If you have any issues, concerns doing this entire exercise into your local or any Kubernetes cluster of Google, and if you have any issues while tagging it and pushing it, so feel free to dock your comment section in this our YouTube channel. That this video will be updated and uploaded, and under the comment section, for sure I'll reply on the same back. So that's all for this lecture. I hope it is more knowledgeable, understandable, and it's clear for everybody. And thanks for watching, and share this video to the person who willing to learn MLOps, all the CI/CD stuff and all. Thanks for watching. Until then, bye bye.